Zeal Education Society, redefining excellence.
Hello, good morning to everyone. I am Dr. Mahadev Unde, Professor, Zeal College of Engineering and Research, Pune. Welcome to Basic Electrical Engineering lectures. We have started the DC network, and in the previous video lecture we have learned how to write the matrix or how to solve the Kirchhoff's laws by inspection only, that is by matrix method. In this video lecture we are going to solve the two numericals based on this. See, let us consider this circuit, and it has been asked to find out current flowing through 6 ohm resistance using Kirchhoff's laws. Nothing is mentioned here, but we can use the loop analysis and put the elements into matrix and use the calci and find out the solution. It is the easiest way. So here let us consider here are the two unknowns, two loops, two mesh. We can consider the two currents, say the current I1 and say this current is I2. So here we have to find out I2 because it is asked to find out the current flowing through 6 ohm resistance. However, you can find out the current flowing through each and every element also. Okay, so let us start now. So as here are only two unknowns, two mesh, two closed path, there will be two unknowns, that is current I1 and I2, and the matrix will be 2 by 2 matrix. Okay, so here it is. Say this is I1, I2. Okay, R11. Sum of all the resistances through which current I1 is flowing. So I1 is flowing through 4, 2 and 1. So it is 7 and it is always positive. Then R22, sum of all the resistances through which current I2 is flowing. So I2 is flowing through, see, let us start from this, 3, 6, 2. So 9 and 11, and these diagonal elements are always positive. Then R12 equal to R21. R12 sum of all the resistances which are common for current I1 and I2. So which resistance is common for I1 and I2? 2 ohm. So here will be 2 ohm. Now see, the I1 is flowing through 2 ohm in a downward direction, whereas I2 is going in upward direction, means they are flowing in opposite direction. Therefore you have to give the negative sign here. Okay, then put I1, I2. Now come to the voltage matrix. Now let us start this first loop I1. You can start from any point, but you have to reach the same point again. Means you have to complete the closed path. So this I1 is flowing through 4 ohm. See I1, see the direction. The current I1 is entering into negative terminal of the battery first. Therefore here will be -6. Current is entering, I1 is entering into positive terminal of the battery first. Therefore it is -6. Then go ahead and it is entering into negative terminal of the battery first. Therefore it is +16. So it is +16. So it is equal to actually 10. Okay, or equal to, we can write here 10. Okay, then what about the second loop? See, we have to consider all the batteries, all the sources, energy sources encountered while traveling along the closed path. Okay, and that's why I have selected such a kind of numerical. Okay, for the second loop, let's start from here. And here it is observed that the current I2 is entering into negative terminal of the battery, and therefore here it is plus sign, so it is +6. So here it is at +10 and +6. So you have to use the calci or check it once again. R11, 4 + 2 + 1, 7. R22, 3 + 6, 9 + 2, 11. These diagonal elements always positive. Then R12. See, these currents are flowing in opposite direction, therefore -2, R12 equal to 2, 1, -2, I1, I2. Then the batteries. The current I1 is entering into positive terminal of the battery first here, and therefore minus 6. Then it is further entering into negative terminal of the second battery, therefore it is plus 16, and that is equal to sum is 10. Then for the second loop, the current I2 is entering into negative terminal of the battery first, therefore positive sign, and therefore it is plus 6. Now use calci and find out the solution. Go to mode, press it. Now for equation there is 1, so I have pressed 1. How many unknowns are here? 2 unknowns, so press 2. So it will be A1 is 7 equal to B1 minus 2 equal to C1, that is 10, equal to A2 is minus 2, then B2 is 11, then C2 it's 6 equal to, that is 1.671 and equal to 0.849. So let us check it once again. You can continue. A1 7, A2 minus 2, C1 10, then the A2 minus 2, B2 11, C2 6 equal to. So here it is I1 equal to 1.671 ampere and I2 equal to, press equal, 0.849 ampere. So this is the current through 6 ohm resistance. Now if you want, what is the current flowing through 3 ohm resistance? Current flowing through 3 ohm resistance is, current through 3 ohm is I2, and that is 0.849 ampere. Okay. Then current flowing through 4 and 1 ohm is I1 and equal to 1.671 ampere. Now current through 2 ohm. See, I1 is bigger, so it is equal to I1 minus I2. So I1 is 1.671 minus I2 is 0.849, and that is equal to. See, you have to come out from these modes. That was for the solving the equation, solving the matrix. Okay. Then 1.671 minus 0.849 equal to 0.822 ampere. This is through 2 ohm. See, actually we have solved for all the resistances, but in the examination it may be asked find the current flowing through 3 ohm resistance or a 4 ohm resistance or a 6 ohm resistance. The question can be asked any means. Let us have one more numerical. Say, consider this simple network like this. So this is 2, this is 3, say this is 4, say this is 5, so this is battery here, and here it is one more battery. Say here it is 100 volt, say here it is 50 volt. Okay, so here are also 2 closed paths, that means 2 mesh, 2 unknowns. Let us mark them like this. Say I1. You can consider either clockwise or anti-clockwise, whatever you like. Okay. We have considered both in a clockwise direction. Now put the matrix directly by inspection only and solve it by using the calcium. Okay. So here it is. Current I1 is flowing through 6 ohm resistance. Then current I2 is flowing through 3 plus 5, 8 plus 4, 9. And these diagonal elements are always positive. Just a minute. 3 plus 5, 8 plus 4, 12. Okay. Okay. Then R12 equal to 2, 1. 1, 2. Sum of all the resistances common for current I1 and I2. So here it is 4, here it is 4. And what should be the sign? As they are flowing in opposite direction, give the negative sign. Okay. So here it is I1, here it is I2. Okay. Then the battery. Okay, so current I1, let us start from this point. Current I1 is entering into negative terminal of the 100 volt battery, and therefore it is plus 100. Okay, then current I2, say let us traverse like this. Current I2 is also entering into negative terminal of the battery first for the 50 volt, and therefore it is also plus 50. Okay, if you consider in opposite direction also, you can check answer, you will get the same solution. Okay, and that is the homework to you. Now use the calcium and solve it. A1 is nothing but 6 equal to B1 minus 4 equal to C1 100 equal to A2 minus 4 equal to B2 12 and C2 50 equal to I1 is 25, I2 is 12.5. So let us check it once again. See, A1 6, B1 minus 4, C1 100, A2 minus 4, B2 12, then C2 50. So I1 is 25 ampere and I2 equal to 12.5 ampere. You have to press it once again, or you can use any YouTube video how to use the calcium. Okay, so the current flowing through, here it is, say AB. It is asked to find out current flowing through 5 ohm resistance. So this is the current flowing through 5 ohm resistance. This is the answer. Now the same question you can solve by other way also. Let us choose the direction in counterclockwise direction. Say current direction of I2 is CCW, counterclockwise. Then see, this will be 6. Now as it is in counterclockwise, that will be plus 4, and this will remain same. Now see, this I1, now I1 is entering into negative terminal of the battery first, so plus 100. Now the I2 is in counterclockwise direction we have considered, and therefore it would be, here it reaches to positive terminal of the battery first, therefore negative sign, minus 50. So solve it by using calcium. So matrix method, once again, A1 6 equal to B1 plus 4, C1 100, then A2 plus 4, B2 12 and C2 minus 50. So answer is X is 20 and this is minus 12.5. Check it once again. A1 6, 4, 100, then 4, 12, minus 50 equal to this. So here it is 25 ampere, this is minus 12.5 ampere. Negative sign indicates that the assumed direction is not correct one. The actual direction is opposite to that of the assumed one. Indicates that actual direction of current I2 is opposite to that of the assumed one. That is, we have assumed counterclockwise direction, but actually it is flowing in clockwise direction. That's why here answers are positive, indicate that the assumed directions are correct one. But no matter, you can consider any direction of current. On solving the question, if the answer is found negative, then the actual direction is opposite to that of the assumed one, and if it is positive, assumed direction is the actual direction. Okay, I hope you understood it, and we will stop here. Thank you.